packet, and whoever is destined for, only they will be replying back. So what happens is everyone will be getting the packet. So if a hacker is there in between, he can hack all the packet. He can get all the packets and he can check what is in that packet. So he can hack it easily. That is one issue if you are using a hub. So the next thing is, if one of the machine is going to send a packet, all the others should be like listening to that. Okay, it is not a full duplex device, it is a half duplex device. So only one person can send at a time, and all the rest should be listening to that. So that is a half duplex device. And third thing is, if do you know what is a broadcast traffic, broadcast, unicast, and a multicast? Anyone?
So if I remember correctly, broadcast sends to everyone, multicast sends to multiple devices, unicast sends to one device.
Yes, that's it. So there are mainly three types of packets. One is unicast. Unicast means one-to-one. So if I'm sending from one machine to another machine, okay, that is unicast. If I'm sending to a group of machines, that is multicast. And third one is if I'm sending to everyone, that is broadcast. So if in the case of a hub, if one machine is going to broadcast, so all the machines will have to reply for that. And if there is any loop coming in between, then all the systems will be like stuck. And only if the loop is removed, only we can send the packet again. So these three are the main disadvantages of a hub. So what they found out is switch, and switch is an intelligent device. So it is having, as you said, it is having a MAC address table. Whenever I connect a machine to a switch, the initial step is it will be in the learning phase. So it learns the MAC address and it writes down the MAC address and the port from which it received the packet. So in that way, it is creating the MAC address table. So once all the machines have sent a packet, it gets the MAC address of all the machines connected to the switch, and the MAC address table will be full. And next time when a packet is sent to a destination, it will be correctly forwarded only to the destination port. So only the destination port receives the packet. So there is no point, like nobody can hack the information. Okay, that is the advantage of switch. And next thing is switch is working in a full duplex device, full duplex mode. So I can send and receive the packet at the same time, and like multiple person can send the packet at the same time. So that is full duplex. And the third thing is about the broadcast. So we can divide this broadcast, like broadcast domain can be divided. If there is an accounts department and a managers department connected to the switch, so I can divide these two, like logically I can divide it into two, and we can divide the broadcast domain. So these three are the main advantages of switch, and there are L2 switches as well as L3 also. Now most of them are using L3 switches. Like these switches can be used for routing purpose also, instead of having another router. We can route the traffic using L3 switches. And for in the case of router is used for routing traffic from one network to another network. So if I'm having two networks connected in a switch, so what happens is whenever the traffic from one network to another goes to another network, switch won't be able to forward the traffic to the next network. So we need a router for that. So router means to route the traffic from one network to another network. Okay, these are the difference of all these three devices. These are the three devices mostly used in a network. Okay, so like how, to what extent you know about IP addressing, like subnetting, classes?
Also, I want to ask, can like layer 3 switch replace router, or it's more like support device?
Yeah, we can use a layer 3 switch instead of a router, but router means it is only for routing purpose. So most of the routing features like BGP, OSPF, that won't be there in switch, like L3 switch.
So
You can,
about IP.
yeah.
Oh, okay. So you can
Like
continue.
natting features that won't be there in this L3 device, L3 switch. Like basic L3 function, basic routing functions we can have use in L3 switch.
Okay, thank you.
So mostly it comes like if I'm having two or three different VLANs, we can route the traffic between these three VLANs. That is possible in L3 switch. Okay. Okay, about IP addressing. So to what extent you know IP address, because you might be configuring the IP address in devices. You just want to know like whether you understand class A, class B, class C addresses and the difference between these three. The subnetting part.
So as I know, we can use only ABC network classes.
Okay.
So it's private IPs, right?
Not which one? Class A, class B, class.
Oh no, wait. We have ABC classes, and we have some pools which assigned to IP, private IP. Sorry.
Yes. So there are mainly three classes which we are using. So if we are going to IP address, we are having from, it is a like 32-bit addressing and a dotted decimal format. That is a format for IP addressing.
Sorry, can you repeat last sentence?
Yeah, it is dotted decimal format. IP addressing is dotted decimal format.
Okay.
So, for example, if we are writing it is dotted decimal format. So if you are using 192.168. Hello. Yeah, if you are using 192.168.0.1, that is what I am saying, dotted decimal format. Okay, it is a 4-octet. So 4 octets will be there, and it is written in dotted decimal format. And we are having different classes of IPs. So class A will be from 1 to 127. Class B will be like the starting octet. Okay, if an IP address starts from starts between 1 and 127, like 126, we can write it as 126. So if an IP address starts from 1 and 1 to 126, then that is class A IP. Okay, class B will be from 128 to 191. It will be starting from 128 to 191. And class C will be 193 to 223. 192 to 223. Okay. Any doubts in that?
Yes. So, but we cannot use 127. It's loopback address, no?
Yeah, 127. That's what I was saying, like 1 to 126. Okay.
Okay.
And the next one will be 128 to 191. Okay. Third one will be 192 to 223. So in between 127, I have left out 127. So 127 is a loopback IP. Okay. Loopback means to check whether our network card is properly installed. So if I'm having a machine and network card is properly installed, so I can do a ping to 127 range IP. 127, normally we use 127.0.0.1. If it is getting a reply, if I'm getting a reply for 127.0.0.1, that means the network card is properly installed. So 127 is reserved for loopback testing, or we can say whether the network card, the driver, everything is properly installed. Okay, so we can use any IP starting from 127. We can use 127.0.0.2, 127.10.10.2, any IP. All will give you a reply. Have you tried that? Anyone?
Sorry, what was the question?
Yeah, anyone has tried pinging to 127 range IP, 127.0.0.1 or 127.0.0.2, any IPs? Okay, from your machine, if there is a machine, if you can try that, like 127 ping to 127.0.0.1, you will get a reply for that. Okay, so that means your network card is properly installed. To check that only, we are using this loopback address. And also one more IP is there, 169.254, that is starting with 169.254. Okay, any idea of that, this IP?
Is it IP per IP?
Yes,
Or no?
yes, that's it. So Microsoft, that belongs to Microsoft Apipa IP. So if there is no DHCP server in our network, we will be getting the IP from like auto IP starting with 169.254. Okay, that is in the case when we have given a like obtain IP automatically and there is no DHCP server. So whenever you are troubleshooting something and you are getting the IP as 169.254, that means DHCP server is not reachable, or DHCP server is like switched off or something. Modem is switched off, something like that. Okay. For each range, okay, for class A, class B, and class C, a few IPs, like IPs will be up to 255. So from 224 to 247, it is multicast IP. Okay, so these IPs, these multicast IPs, we won't be using in our machines. So these will be used by software team to develop their softwares. So if they are developing some multicast software, then they will be having any one of these IPs, like starting from 124, 224 to 237, 239. Okay. So again, there is some more left out, like 240 to 255. That is for experimental purpose. So normally, what we use is from 1 to like 223. That is the range we will be using. Okay. So 1 to 126 is class A IP, and class A for each of these classes, we will be having a private range and as well as a public range. So any idea, like anyone, what is public and private? Public IP and private IP.
So public IP, it's IPs which internet providing are using. Private IP, it's IP which you using in your local network.
Okay. Yes.
So you basically get one public IP, and then router assign private IPs to all your devices.
Okay. So if I'm having an office, so internally I will be having around 30, 50 machines. So for each machine, I need an IP address. So if I want to access the internet, I will need a public IP. For internal LAN, we will be using a private IP. If I want to access the internet, then I need a public IP. So there is a difference. Only the public IP is routed in internet. Private IPs are not routed. So in class A, 10 range IPs, like starting from 10, 10.0.0.0 to 10.255.255.255. That range is completely private range. And in class B, it is 172.16.0.0 to 172.31.255.255. Okay, and for class C, it is 192.168.0.0 to 192.168.255.255. That is, these are the class public IP, private IPs for different classes. And all the rest are public IPs. So if I am having 50 machines internally, and I have assigned 192 range IPs for all these machines, all these machines has to reach to internet. So to reach internet, all devices should be having a public IP. So if I'm having 50 machines, I need 50 public IPs to access the internet. Okay, so if all of the like the whole world is going to access the internet, okay, we don't have that much of public IPs with us. For that purpose, we are using NATing. Okay, so NATing means it will be translating the private IP and private IP to public IP and reverse, public IP to private. So what is NATing? Network address translation. Normally we enable NATing in the modem or router, whichever we are going to install at customer side. We will be enabling this in NATing in this device. Okay, what NATing does, that is whenever a machine, like internal machine, is going to access the internet, it comes to the router, and a router will be translating the private IP to the public IP. Okay, and it will be having a translation table in that. So whenever it is going out, it will be writing the details, like this person is going out with this IP and this port number. And when the reply comes back, it will be translating back to private IP, like public to private also is handled by this NATing feature. For all the routers, modems, everything will be using this feature, NAT feature. So if whenever this NAT feature is disabled, you won't be getting the internet. Okay. So for NATing also, there are like three different variations in NATing. So one is one-to-one NATing. Okay, one-to-one NATing means if I'm having a server inside and that server needs a public IP, like it will be dedicated for that server, that public IP. So that is one-to-one. So whenever this server is accessing, like going to the internet, it will be using that particular IP, and that particular IP would be only for the server. That is one-to-one. And the next thing is one-to-many. Okay, that is what we are using now. That is another name is PAT, port address translation. So that is what currently we are using, and that means all the machine, if I'm having like 300 machines, all the 300 machines can use a single IP, single public IP. Okay, any doubts in this?
I just want to ask, what is difference between NAT and PAT? PAT.
Yeah, NAT means network address translation, that is having like one-to-one. PAT means it will be adding a port number also. Okay. So if it is a NAT table, then we can see the source IP like 192.168.0.1 and the translated IP. It is a public IP. Okay, only that will be there. So in the case of PAT, the port number also will be mentioned. So if I am the source machine, all the packets will be having a source port and destination port. So do you know about port numbers? What I mean by port? It is not the switch port. I'm talking about the TCP port number. Do you want me to explain that?
No, it's okay. It's enough for now.
Okay.
Thank you.
Okay. So the port numbers means the whatever is used in the transport layer. Okay, the TCP port number. So that port number also will be noted in PAT table, port address translation. So only if that port number is mapped, then only we can use one-to-many. Okay, otherwise it will be like one-to-one. If port number is not mentioned, then one source, one destination, like one source will be translated to one public IP. Okay, for each of the 50 machines inside, I need different IP address, different public IPs. So for that only we are using PAT, port address translation. So here what happens is we will be in the table, you will be having source IP address, then source port, then destination IP, destination port. Okay, then the translated public IP, and if they wants to translate the port number also, they can do that. Okay, all these details will be there. Only if the router is having these details, it can use a one-to-many communication. Otherwise, it will be one-to-one. For that only we are using port address translation. Currently, all of the devices are using port address translation.
Okay, thank you.
Okay, so anything else you want from the netting side? Like one more is there. We will be having, if I am having say 4 public IPs, I can define these 4 public IPs in a pool, okay, in an IP pool, and from that pool, whoever comes first will be getting the first IP, the second person will be getting the second IP, like that it will be taking. Okay, that is also there. Okay, but normally what we use is PAT, port address translation. So if I'm assigning a group like 5 IPs in a pool, then the 6th person will have to wait. If any of the initial 5 persons get the reply from internet, then this IP will be back to the pool, and the 6th person can use internet. Like that, it will be good. So normally we use PAT, port address transfer. We won't be using this like one-to-one or from the pool. We won't be using. But for server side, we'll be using one-to-one. If a particular server needs a public IP, dedicated public IP, we will be using one-to-one. Static netting will be used. Okay, so how we can like differentiate between the networks? If I am saying 192.168.0.1 and 192.168.1.1, okay, anyone can say whether these two are in the same network or different network. 192.168.0.1 and 192.168.1.1, whether these are in the same network or different network. Rocky.
Yes.
Oh, you are driving. Okay, then, okay. That's, Hamid, can you say whether
we can?
Yeah, Roman, please.
So we can say if IP address in same network looking on subnet mark, the subnet mask.
Yes.
Yeah, so I don't remember which address you named, but I think it's type C address. Default subnet mask is class C. It's 255, 255, 255. So
yes,
if last octet is different, it's in same network. If like third octet is different, it's in different network.
Okay, so based on the subnet mask only, we will be understanding like whether it is the same network or different network. Okay, so if in a class A, the default subnet mask is 255.0.0.0, so that means the first octet should be same. So if I am writing 10.0.0.1 and 11.0.0.1, so the first octet is different. One is having 10 and the next one is having 11. So those are in different network. Okay, for class B, the first two octets, that is the subnet mask will be 255.255.0.0. So the first two octets will be the network part. So if the first two octets are same, then it comes in the same network. Otherwise, it will be in different network. For class C, it is 255.255.255.0. Okay, so the first three octets should be same. The first three values should be same. If it is 192.168.10.1 and 192.168.10.2, both are having the first three values are 192.168.10. So both are having same, so it is same network. So likewise, we will be knowing whether the devices are in the same network or in a different network. Okay, so how a machine knows whether it is having same network or different network? Like if I'm going to my destination, okay, for example, my machine's IP is 192.168.10.1. Okay, and my destination, I am going to ping to an IP 192.168.20.1. So how the machine knows whether the destination is in the same network? What happens in between?
So I think it's in router. We have ARP, which translates from IP address to MAC address.
Yes. So whenever we configure a machine, we configure the machine IP, then the subnet mask, and third thing is the default gateway. Okay, so what is default gateway?
So if router doesn't know where to send packet, it sends to default gateway, right?
Yes, yes. So in the case of a machine, I'm talking about the machine. So machine will be having a default gateway. So what happens is, whenever I am sending a traffic to a different network, okay, the traffic will be sent to default gateway. That is, default gateway means my router IP. Okay, so the machine needs to understand whether I am sending it to the same network or to a different network. For that purpose, like I said, it will also compare with the subnet mask and the IP address. Okay, the subnet mask is 255.255.255.0. Then it checks for the first 3 octets for source IP and destination IP. If both are same, it won't send it to the default gateway. Instead of sending it to the default gateway, it straight away sends the packet to the switch. Okay. If it is in a different network, what happens is it will be sending the traffic to the default gateway, that is to the router. And once the traffic reaches the router will be checking its routing table. Okay, it will be having a routing table, and in the routing table it mentions which are the networks connected to the router and which are the ports for those networks. If I am having two network 192.168.1.0 and 192.168.2.0, the router will be having a routing table with 192.168.1.0 connected to like Ethernet 0 and 192.168.2.0 connected to Ethernet 1. That details will be there in the router. So if a traffic is coming to the router destined to 2.0, 192.168.2.0, it will be checking the routing table and it will be passing the traffic to Ethernet, like whichever port it is connected. So that way the router will be routing. So router will be having a routing table to route the packets from one network to another, and switch will be having a MAC address table to route the traffic to the correct machine. Okay, so these are the basic functions, okay, for switch and router. Any questions on this? Should I like explain the ARP traffic, or you know that how ARP is working?
All I know is that ARP is like translate MAC address to IP address, but I don't know how it works.
Okay, so ARP table means it is MAC address to, like, if there are 50 machines in our network, so we won't be knowing the MAC address of each of these machines. Okay, but we might know the IP address of these machines. Okay, because MAC address is 48-bit address, and also it is in a hexadecimal format. Okay, so it is like very difficult for knowing the MAC address, but it is easy for this numbering format IP address. So we will be knowing only the IP address. Like if I want to send a traffic from 192.168.0.1 to 192.168.0.2, whenever the traffic is getting created, it is having a transport layer where the TCP port will be added, source port and destination port. Next layer is network layer. So there we will be adding the IP address, source IP and destination IP. And the next layer is data link layer. So there we need source MAC address and destination MAC address. So whenever traffic needs to go out from my network card, it needs to know the destination MAC address also. Only then we can send a packet out. Okay, so to get the destination MAC address, we will be sending out an ARP. Okay, address resolution protocol. We will be sending out an ARP request. So in the ARP request, it will be having the destination IP address, and it will be sent out as a broadcast. So it will be sent out to all the machines in the network. So all the machines will be opening this ARP packet, and whoever is the actual machine, he will be sending out his MAC address. So if the traffic is going to the destination is 192.168.1.2, then all the 50 machines will be receiving this ARP packet, ARP broadcast, and 192.168.1.2 will be replying back with its MAC address. So that will be received at this machine, the source machine, and it will fill the destination MAC address, and then the traffic will be going out. Okay, so for next time, if I want to send the traffic from my machine to the same machine, I won't be using this ARP because I will be storing this detail in my machine. So in our system also, like Windows machine also, there is an ARP table, like it having in switch, not in switch, in router. Our system will be having ARP table. So in the system, it will be written, the MAC address and the IP address will be stored there. Okay, so the next time it won't send an ARP request, it will be taken from this ARP table. For that purpose only, we are using ARP to find the MAC address of the destination machine. So if I'm not having this destination MAC address, I won't be able to send the packet. For this, we are using ARP. And one more thing is that normally it is 300 seconds only this data will be stored. Okay, not more than 300 seconds. So after 300 seconds, it will be flushed out. So if I'm not going to send the traffic to this same destination for 300 seconds, then it will be flushed out, and next time, again, it needs to send an ARP request. This is the same for router also. Router also will be storing this MAC address only for 300 seconds. That is a default value, we can change it. Okay. Any doubt in this, or anything I need to clarify? It's Roman, no?
Sorry, what?
No, your name is Roman, right?
Yes, Roman.
Okay, so any more like clarification needed for the ARP?
Not now. I don't have any question right now.
Okay. No, did you get what I was saying?
Yes.
Okay. So, what all things you will be needing from my side? What all type of topics you need.
First, probably, I would like to know how to troubleshoot some problem. For example, if we have like speed drops, what could it be and how to find it?
Okay.
Also, like I would like to know more about like routing, like what difference between, for example, IRGP and ERGP, something like that.
Okay.
So it's all what I have right now.
Okay. Others? Hamid? Hamid?
Yeah, I don't know right now, so I have to do research on it.
Okay.
Do you
More?
want to give any input?
I'm sorry, do you ask me something?
Do you want to give any suggestions for the topics for training?
Actually, yeah, I'm listening. I have knowledge about everything he talks about it.
What about more?
Also, I want to add maybe like there is some like good practices. What security we should use? Maybe like for example STP. Do we have to configure something, or can we use like default one? Something like that.
Switching side.
Yes.
More?
Mo, do you have any suggestions on topics for future training sessions?
I'm okay with everything. I guess we gotta get the beginning of the system is whatever doubts they got and whatever. Still, I do have a few questions, but a little bit way a little bit more advanced than these, like backslapping, things like that.
Yeah.
That but for now, I guess that's okay. How often we're gonna have these sessions? You think?
So it will be once every week on Fridays from 7 a.m. to 8 a.m. We will also be providing, suggesting some training materials. We will provide some training material like a good book or a online material we will be providing for the text to refer and go through as well. So we may not be able to cover all the topics on these sessions, but if our techs can take their own effort to go through the materials and select some topics for the sessions and ask doubts, then that will be great if we can continue the training sessions based on what our technicians want. One suggestion I have, Swastik, one suggestion I have is that we need to do one session on PRTG because Mo knows everything, but others, Rocky, Roman, and Hamid, are not quite that familiar. I would say Hamid Hamid at least know how to check the alarms. Roman and Rocky has not even seen PRTG. So if we can take one session on PRPG, that will be great. That will benefit with their day-to-day work as well.
Okay, we'll do that, Rasmi. So can we wind up for today?
Yes, we can wind up for today. Guys, if you have any doubts regarding today's session, you can always put in your doubts or questions in the group. Specific will review it and address it later in the next session or before that. So you can also give us feedback regarding the session to make it a bit more better. So we will all meet again. So we will end the session for today.
Thank you, guys. That was great,
Thank
guys. Thank you for your time. Thank you very much.
Thank you.
Thank you.
all.
Thank you.
Thank you.
All right, thanks.